we're going to get started on lesson 4.1 and 4.2. We'll start by thinking about how probability and random events occur in our world and how we can start to describe them from a statistical perspective. And so we introduce you first to the term random variable. And so looking at the definition here, random variable is a variable whose quantitative value is determined by a random event. And we'll talk more about this idea and how we use this idea of random variable and how we apply that to events that happen in the world. So again, thinking about random variables, there are two types similar to the variables we talked about earlier in the course, discrete and continuous. And to give you an example of just thinking about a random variable would be how many siblings does a student have in the class, right? And so if you had to predict, right, what percentage or what proportion of students, right, what proportion or what's the probability that in this class someone has 0 siblings or 1 sibling or 2 siblings, right? What's the probability? And you thinking about that would be what we're looking at here in terms of a random variable and looking at its distribution, which we talk about. In this case of number of siblings that we're talking about, if you had to guess that, that would be a discrete random variable because it's countable. We're able to list it out, right? There's not an infinite number of ways to do that. Even if you say a half a sibling, right, it would still be considered discrete versus continuous. And so here are some examples that you could read of the different types of variables that would fall into those categories. What we're going to end up talking about in these sections are something called the probability mass distribution function and the probability density function. And they both show you the distribution of a random variable, right? How often the likelihood of that event occurring. It's just one will be done for a discrete random variable and the other for a continuous, which we'll talk about as we continue on, which then we revisit the idea of probability distribution of a random variable, right? We also call it a probability model. And so what we're looking at here is all the values the random variable can take, right? When we think about a distribution, right? And how often. In this case, it's the probability for the values of the random variable, right? And so again, that's the idea of frequency, but just as a proportion or a percentage. Here's an example of a probability. Here's an example of a probability distribution of a discrete, right, probability density distribution function. Here's an example, right? The number of years it takes to earn a bachelor's degree is given in this table. And so looking at that data here, you will see the random variable is the number of years to earn a BS, because that will vary from person to person. And here is the percentage or proportion of students who finish the degree in that amount of time. And so you have that distribution. You have the values, right, that the variable can take, and the probability or the percent or proportion of a proportion of how often those values, right, how often those values occur. In this case, what does it mean that the values 0, 1, 2 are not included in this PDF, this probability distribution? It's because those values aren't possible, right? We have no one who graduated in 0, 1, 2, so their probability is 0. And so that's what we're looking at. That's what we're going to be talking about as we think about random variables and move into a more statistical perspective of that.